to question 3 of the alkanes tutorial. So this is a past A-level question saying that alkanes are very unreactive. So just 2 reasons why this is the case. So this is actually exactly from the lecture notes. There are 2 reasons to explain why alkanes are very unreactive. Number 1, alright, alkanes contain CH and CC single bond. Alright, so first of all, these bonds are very strong and requires a large amount of energy to break. So for any chemical reactions, you need to break bonds, alright, in order to form new bonds. So the carbon-carbon bond and the CH bonds require a large amount of energy to break, and therefore this causes alkanes to be unreactive. Okay, the second reason is because alkanes are saturated and non-polar. So if you think about alkanes, what does saturated mean? Saturated means all single bonds, right? So all single bonds. Non-polar means what? Non-polar means there's no delta plus or delta minus. There's no difference in electronegativity. So when they are saturated and non-polar, what happens? Alright, they do not contain any region of low or high electron density. Okay, so because they are all single bonds, there's no pi bonds, there's no high electron density region, there's also non-polar, there's no delta plus or delta minus in the molecule. Therefore, as a result, they do not attract electrophiles or nucleophiles or polar molecules. So they will not attract any electron-poor species, electron-rich species as a nucleophile, or any polar molecule, because itself is non-polar. There's no delta plus or delta minus charge to attract this species, and therefore it is difficult for it to partake in reaction. Okay, moving on to part 2. So again, as I said, this is largely a learning objective that you need to know in your syllabus. So this is actually a bookwork question. Alright, so you can refer to the lecture notes for this exact same phrasing as in your lecture notes. Moving on to part 2. However, alkanes such as propane do react with oxygen and with chlorine. For each of these reactions, there are 3 things to need to state: the conditions that which the reaction is undergoing, the type of reactions, as well as an equation for the reaction. So the reaction with oxygen is actually, the type of reaction is actually your combustion. Okay, the conditions, so this is the type of reaction. Okay, so number 1, 2, and 3. Alright, so this is your point number 2. Propane undergoes combustion. The condition is that you must heat it with excess oxygen. Alright, so just like how we combust your hydrocarbons, we need to heat it with oxygen. Alright, to undergo complete combustion, we therefore need to heat it with excess oxygen. So in this case, propane C3H8 reaction with oxygen, how will we balance the equation? Alright, we need 5 oxygen. Alright, why so? Because the product it's CO2 and H2O. So how will we balance this equation? First of all, we balance the carbon first because it's one of the easiest elements to balance. Why so? Because carbon only appears once on the right hand side in CO2 and also once on the left in propane. For 3 CO2, next we balance hydrogen. In total, we have 8 hydrogens, so therefore we need 4 water molecules. Alright, so 4 times 2 hydrogen. Alright, 4 times 2 hydrogen, you can therefore get 8 hydrogen atoms. Therefore, over here I have 4 oxygen atoms plus 6 oxygen atoms. In total, I need 10 oxygen atoms. 10 oxygen atoms in terms of molecule will be back to 5O2. And that's how I get 5O2. And this is how I get the balance equation for the combustion of propane. So notice here in propane, I wrote out the structural formula. Why so? Because the question specifically asks for propane. So it's important that we show the correct structure formula. So that's why you can see me writing CH3, CH2, CH3. Okay, for the reaction with chlorine, this will be your free radical substitution. Alright, so in this case, the type of reaction with chlorine is your free radical substitution, not halogenation. This is a common mistake made by students as they first start on organic chem. When the question asks you for the type of reaction, okay, typically they are asking for not the name, but the mechanism in which the reaction is carried out. So in this case, the reaction with chlorine participates via a free radical mechanism. So this is the type of reaction that's happening. Alright, and the conditions required will be with limited chlorine in the presence of UV light. Okay, so this is the condition required. Okay, so again, these are things that we'll cover in lecture earlier on. Why do you need UV light? You need UV light to help break the Cl-Cl bond homolytically, alright, so to generate radicals. Limited is for us to get mono substitution. Alright, so limited for mono substitution. UV light is for the initiation stage. To break the Cl-Cl bond. Okay, so initiation stage to break the Cl-Cl bond to generate your free radical. Okay, so to write a balanced equation, the question did not ask us mechanism, and therefore it's an overall equation that's required. So we have our propane reacting with chlorine, Cl2. In this case, only one of the hydrogens will be replaced. Alright, so in this case, I can choose the middle chlorine atom to be replaced, or the terminal carbon to be replaced. So it's either I substitute at carbon number 1. In this case, I'm substituting at carbon number 2. In this case, I'm substituting at carbon number 1. Okay, so you can see that there are two different products that can be formed. It's either you substitute at carbon number 1 or carbon number 2. The byproduct will be HCl because the hydrogen that's being replaced will combine with the other Cl to form HCl as a byproduct. Okay, so this is how you write your balanced chemical equation. Okay, if not, the next video we'll be looking at free radical substitution before we discuss question 4.